One of the great features to come out of Server 2012 was storage spaces, which provided us with a way to virtualize all of our underlying physical storage into one or more storage pools. That layer of abstraction, combined with many of the sweet features Microsoft built into storage spaces, gave us a really economical and easy way to design, manage, and use our physical storage. So in this nugget, we're going to take a quick overview of what storage spaces are all about, get you up to speed here on all the components and some of those great features, and then we'll jump into the virtual nugget lab and we'll learn how to virtualize our storage. In previous nuggets, we've created volumes directly from our physical disks. We're going to take that same storage layer and virtualize it and create volumes from our storage spaces. Let's do it. In previous nuggets and prior to storage spaces, creating volumes meant slicing up those physical disks directly. Storage spaces abstracts and allows us to virtualize by injecting two more layers between our volumes and our physical disks. That first layer is known as a storage pool. This is the layer where we pick what physical disks we want a part of the pool and we group them together, and we can create multiple storage pools that target different disks. These disks can vary in size, they can vary in type, SSD or HDD, and combining them is a good idea because we can take advantage of the tiering feature. We'll talk about that in a little bit. And they can also vary by interface. They can be a mix of USB, SATA, SCSI, iSCSI, SAS, just to name a few. It works with locally attached storage or directly attached disk enclosures, otherwise known as JBODs, just a bunch of disks. Now, once we've grouped our disks into one or more storage pools, we use those storage pools in the layer above it, known as storage spaces. Now, in the UI as well as PowerShell, they're known as virtual disks. And I know the naming is a little funky here because these are not the VHDs and VHDXs we know and love. They're virtual disks entirely in the context of storage spaces. So this is the layer where we actually use the storage in a given pool. So when we create a virtual disk, we're going to specify what pool we want to allocate that storage from. We can use fixed or thin provisioning, and we also specify our resiliency settings. This is one of those sweet features that make storage spaces so economical. We don't need to deal with hardware RAID and buy expensive RAID controllers. It's built in to storage spaces, and it works by spreading our data across multiple physical disks. Let's go over each one of these. Simple is the equivalent of RAID 0, and it actually doesn't provide us with any resiliency because it just simply stripes our data across all of those physical disks. So there's not going to be any extra copies of our data stored anywhere at this layer. And this is useful for high performance workloads where data loss is acceptable. Next up, we have a mirror. This is the equivalent of RAID 1, in which any block that is written to our storage pool is copied to another physical disk in that pool, providing us with redundancy. Our storage pool under a single mirror can now withstand up to a single disk failure. We also have support for a three-way mirror, which requires 5 physical disks and allows our pool to withstand up to 2 disk failures. This is the resiliency setting you'll use for most workloads because it protects us from disk failure and provides us with good performance. Finally, we have parity, which is the equivalent of RAID 5. Here it stripes our data along with parity information used to reconstruct data in the event of a failure across all of our disks. Parity is known to give us slower write performance because it needs to stripe that parity information across our physical disks, but better in terms of storage capacity because it's not mirroring all of the data. We'll primarily use this for storing backups and archives. We can take advantage of that storage capacity, and for those workloads that consist of write once and read many, like streaming media. By the way, there's also a dual parity resiliency setting, which is the equivalent of RAID 6. It requires 7 disks and can withstand up to 2 disk failures. Another incredible feature that you'll want to take advantage of here is tiering. This is what allows us to mix disk types. So when we create a pool, we can add some SSDs into that pool and some HDDs into that pool, and storage spaces will actually monitor the data inside of that pool. And it'll take the hot data, the most frequently accessed data, and move it over to the fastest tier, SSDs. And then it'll take the less frequently used data and move that over to our slower HDD tier. And it all happens transparently behind the scenes. You can use PowerShell to pin files to a specific tier. Another great feature that's built in is support for a write-back cache. Now, small random writes can really wreak havoc on our physical layer, right? Especially on our slower disks. So a write-back cache will actually reserve a small amount of space on our fast tier, on our SSDs, to act as a buffer. So all those small random writes that come in will get written onto our fast tier and then later sent over to our slower tier. And that's storage spaces in a nutshell. Once we've configured these layers above our physical layer, then it's just like working with any other disk. We can create partitions on them, format them with the file system, and turn them into usable volumes. And the best part of all of this, because it is abstracted and virtualized, this layer here isn't set in stone. If we run out of storage at any layers above, we can just plug more physical disks in and add those to expand our pool dynamically. With that, let's jump into the virtual lab and learn how to work with storage spaces. I've logged into our single machine for this lab. We're back on FSNUG, our file server, where we have 3 physical disks attached to this machine. But rather than create volumes directly from these disks, we're going to pool them together using storage spaces. So let's go ahead and start here by launching Server Manager. And once it loads up, let's choose File and Storage Services over there in the left-hand nav. Let's start by clicking on Volumes. Notice right now that we have our system partition, and then we have our C volume. Both of these sit on top of a physical disk. In fact, if we choose disks here, we can choose that physical disk and we can see the volumes below that are associated with it. But also notice that we have 3 uninitialized and completely empty disks. These are the disks that our storage pool is going to sit on top of. So let's go ahead and choose storage pools. And at the top here, you're going to see a list of all your storage pools. Once you choose a storage pool, you will see the physical disks associated with it. Since we haven't created any, this is your default pool here, the primordial pool, and it'll list all of the available disks that we can use in our storage pools. Over here on the left, you will see all of the virtual disks that we have created from the available storage pools. So the first step here is to create a storage pool. Let's do it. Let's drop down that task button and choose New Storage Pool. This will walk us through a nice, easy wizard here. Give that before you begin a quick read through and choose Next. Now, we're going to create one pool here for all 3 of those disks. So let's just call this Pool All the Disks. There we go. Give it a description, specify that our primordial pool is where this is coming from, and choose Next. Next up is where we choose what disks we want to associate with this pool. So here we can choose individual disks, or we can hit this top checkbox to hit them all, which is what we're going to do here. We can also specify our allocation type. So automatic is the default, and that just means it's going to automatically allocate volumes to these disks. We could also set this up to be manual, in which case whenever we create volumes, we need to manually assign them to individual disks, which will give us greater control, but also more administrative overhead. We also have a hot spare here. This is cool. This will actually keep that disk idle to the side, just waiting. So if any disk were to fail, this would pick up in its spot. Let's go ahead and choose automatic for all 3 of these and hit Next, and that's it, the end of the wizard. Now we can hit Create. And that's that. Now, when that's done, you'll get a little checkbox that pops up here. We can chain all of these wizards together. Create a pool, then create a virtual disk, then create volumes out of the virtual disk. But I'm going to show you how to do that separately here. So let's go ahead and hit Close. Now, if we choose our brand new storage pool, we'll see the available disks in that pool. Now we're ready to create a virtual disk using the available space in that storage pool. Look at the capacity, 148 gigabytes from these 3 disks. So let's go ahead and drop down that task button and choose New Virtual Disk. It's going to ask you what storage pool do you want to take space from. We only have one. It's chosen by default. So let's go ahead and hit OK. And that'll launch us into the new Virtual Disk Wizard. I'm going to go ahead and choose Next here in the Before You Begin page. Now we just need to give it a name. We'll just call this one Company Data. You can give it a description. If you have SSDs and HDDs, this checkbox will light up, which will enable storage tiers. Very cool. That's as easy as it gets right there for that awesome feature. Then we can go ahead and choose Next. Another really cool feature that I didn't mention back on our whiteboard is enclosure awareness. Let's say that we have a JBOD out there, and in this JBOD we have just packed with disks, right? We've got our machine attached to this one JBOD. We create some storage pools. We create virtual disks with all our resiliency settings. So we've got mirroring going on in here. We've got parity going on in here. So we've got lots of redundancy inside. But it's inside. We only have one enclosure. What happens if that enclosure blows up? Well, all of our data and all of our disks go with it. So enclosure awareness, which by the way requires at least 3 JBODs, so you'll need at least 3 to make this work, and then this checkbox will light up, will ensure that that data is spread across physical enclosures. So once we set up a mirror, now that data will be mirrored across enclosures and will be protected at the enclosure level. Great feature, and that's why this box is grayed out for us. We're dealing with strictly locally attached storage. Let's go ahead and choose Next. Here's where you choose your resiliency setting. Simple, mirror, or parity. Let's go with mirror here since that's going to be used for a majority of use cases, and hit Next. Now we can choose our provisioning type, thin or fixed. So again, fixed will use all of the storage that we define here on the next screen, or we can use thin provisioning, make it as big as we want, and it'll start out with very little and grow up to that maximum size. Let's use thin provisioning here, and let's set this up as, how about a 1 terabyte disk? Even though we only have 150 gigs of storage here, we're going to thinly provision this virtual disk and hit Next. And that's it. Now we're done. We hit Create, and that's it. Notice when this is done, it'll also ask if you want to launch into the next wizard to create a volume. We'll do that separately here, so I'm going to uncheck that and hit close. And there is our thinly provisioned company data virtual disk using storage from our storage pool that's getting its storage from all 3 of those physical disks. Now, something really interesting happened there. Let's head back to the disk node. Check it out. Where are those 3 disks? They're gone. All the operating system sees are virtual disks. Storage spaces claimed those underlying physical disks and said, no way, those are mine. Here you go, OS. You can have my virtual disk. In fact, you can verify that by going into our old school tool here, disk management as well. And this is going to show us the same thing here. It's going to show us that we have our disk 0 that contains our system partition and our C volume, and then there is our virtual disk that's presented to the OS. So the last step here is to slice it up into volumes. You can do that right on the disk tab here. We've got a little volumes area down here to create new volume. You can also do it from, of course, the volumes tab up here, only you'll find that in the upper right. Choose new volume. Both of those will lead you to the same exact wizard. Very similar wizard that we used in a previous nugget when we used the disk management utility to slice up volumes and partitions. So let's go ahead and choose next here. Here we'll choose that disk. There's our company data virtual disk. Hit next. How about this one's going to be our U drive, right? For user data. So we'll make this 100 gigabytes and hit next. Drive letter. Well, let's go ahead and choose U, hit next, and now check this out. File system, allocation unit size, volume label. Yeah, very similar, exactly what we did before. It's just we're doing this against what we know as a virtual disk. What the operating system sees is just another regular old disk. So let's make this one NTFS. We'll set up our allocation unit size there as 4K, and we'll call this one user data. Hit next, hit create, and we're done. Now let's go ahead and hit close. We can open up File Explorer and head here to this PC, and look at that. We have a usable volume ready to go. Only this time, instead of being mapped to a single physical disk, it's using that virtual disk, which is using the storage pool, and its data is going to get spread across those 3 physical disks attached to this machine. So at this point, we could create more volumes. We could create an I volume for IT data, format it with the REFS file system with its own allocation unit size, and we could do it again for our V drive for VM data. Just like we did before, only this time we're working with pooled storage, not individual storage. Now, let's go and reverse this process back to the beginning, and I'll show you how we can do all of this with PowerShell. So the first thing we're going to do here is just right-click and delete our volume. So let's go ahead and delete our volume. It's gone. Now let's head back here to storage pools, and let's delete our virtual disk. Right-click, choose virtual disk, hit yes to blow it away. And then we need to do the same thing with our storage pool. Right-click, choose delete storage pool, and blow it away. Now, another thing we're going to need to do here back in the disks area where we should now see all 3 of our disks again is let's wipe them clean. So right click, choose reset disk and hit yes. That'll reset it back to a state where we can then use it again to create a storage pool on top of. So I'm going to do that for each one of these. There's also a PowerShell command that you can use to do this, by the way, called clear disk. All right, we're back to where we started. If we head back to storage pools, we're back to a primordial pool with 3 empty disks. Now let's go ahead and minimize Server Manager. Let's head back into the file system here, into the C drive, into the Nugget Lab directory. Let's go ahead and launch pscommands.ps1 into the ISE. So our first order of business, again, is to create a brand new storage pool out of those 3 disks. We have the aptly named new storage pool commandlet to help get us there. We're going to use the same friendly name we did back there in the GUI, all the disks. We also need to specify which storage subsystem contains the physical disk that we want to associate with this pool. Now we only have one, and that is this machine itself. So if we were to run a get storage subsystem here, all by itself, it's going to return all of the subsystems. We only have one. If you have multiples, like you have multiple JBODs connected to this machine, then you'll get an entry for each one, and you'll need to filter down with the where object to find just the specific subsystem, so that way it can extract its unique ID and pass it to this parameter. Then we have the physical disk parameter. And here we're going to choose what disks out of that subsystem we want to include into this pool. And there is a can pool parameter on get physical disk. In fact, if we just run get physical disk by itself, notice that we have a can pool property of false for a disk that is currently in use. That's the one that contains our C volume. So that's why we should always pass in can pool equals true here. And then we can put more parameters on here if we just want to target specific disks. But with the can pool property, this will return exactly what we need, those 3 disks. All right, so let's go ahead and create our storage pool using those 3 disks. And that is done. Now we can head back here to Server Manager, and we could give this a refresh, and we should see our all the disks pool is back. Cool, there it is, consisting of those 3 disks. Next step is to create a new virtual disk. Here, once again, we give it a friendly name, specify the storage pool we want to associate it with, specify our size. We don't have more than 150 gigs, that's why we're going to need to thinly provision it, and also specify your resiliency setting name. And there's lots of other parameters on here as well for enclosure awareness and tiering and all that good stuff. We'll stick with this one, hit run selection, and that's going to create that virtual disk called company data, which is again thinly provisioned. Cool, and just to verify that worked, let's head back to Server Manager, drop down tasks, and choose refresh. And now we should see our company data virtual disk down here as well. All right, back to the ISC. Now we need to initialize all those disks. So we can run initialize disk, use the virtual disk parameter, and pass in our freshly created company data virtual disk. This will initialize all of those underlying disks. And the final thing to do then is to create volumes from them. And we're going to store our virtual disk here into a variable. This will actually get all the underlying disks associated with that virtual disk and store it into a variable called VD. Finally, we can slice up that virtual disk into usable volumes. We'll create 3 of them, U, I, and V, with varying sizes, varying file systems, and allocation unit sizes. Let's go ahead and run this, and that'll just take a minute to create all 3 of them. Done, done, and done. Now if we head back to File Explorer, head over to this PC, check it out, there they are. One more thing I want to show you here. Let's head back into Server Manager, and let's say that one of our pools was running at or near capacity. Well, if we have available physical disks that we could use, we could just simply right-click on that pool and choose to add physical storage, choose the disk that we want to add, and boom, our pool magically has more storage without ever touching any layer above it or below it. Pretty cool. If we did need to touch the physical layer below it, and we had the ability to hot add physical storage into this machine, well, we could come up to the task button and choose to rescan storage. After we did that, they would show up, and then we could add that physical storage to this pool. Just one of the many reasons that Storage Spaces rocks. Now, later on in the course, we're going to look at a brand new feature here in Server 2016 called Storage Spaces Direct, which takes all of this to the next level and allows us to combine disks from many machines, local storage included, into one big storage pool. In this CBT Nugget, we took a big look at all the components and features that make up Storage Spaces. I hope this has been informative for you, and I'd like to thank you for viewing.